So last week we tackled about what is mineral and how technology was used in production of materials that comes from it. So we are now in session 8. So first, to easily define minerals, you just have to remember this. Now I can define minerals. So N stands for naturally occurring, I for inorganic, C for crystalline, and D for definite chemical composition, and S for solid. And now let's move to physical properties of mineral. So physical properties of minerals. So mineral have distinguishing physical properties that in most cases can be used to determine the identity of the mineral. So among the properties we will discuss are this one. So this is habit. So first is the habit, and then breakage, streak, transparency, color, tenacity, and luster. So we have here the habit. So habit is the characteristic external shape of an individual crystal or crystal group, or it is the general shape of a mineral, including irregularities due to its growth. So we have here the individual crystals and the aggregate crystals. So individual crystal comes from the word individual. It means that it is used to describe single crystal. And then aggregate crystals are minerals whose crystal comes in groups and form a unique shape. So let's take a look at this. So there are in individual crystal, there are cubic shape, tabular, prismatic, octahedral, acicular, and equant, like this one. So cubic or cube shape or cube-like. We also have the octahedral, which is a rectangular shape or it has 8 sides. And then tabular or tub-like, which is a rectangular shape, and equant, which is a term used to describe minerals that have all of their boundaries of approximately equal length or roughly equal. And then we also have the acicular, which is a long, slender crystal, and then prismatic or abundance of prism face. And then we also have bladed, which is like a wedge or knife blade. And then we have the aggregate crystals who have a shape of fibrous, drossy, radiated, globular, reticulated, botryoidal, dendritic, and stellate. So first, dendritic, which is like a tree-like growth, like this one. And then we also have reticulated, which is like lattice or slender crystals or network-like. And then we also have radiated, which is a radiating group of crystals or radiates outward from a central point. And then we also have the fibers or elongated cluster of fibers or fiber-like. And then we also have drossy, which aggregates of minute crystals. So small crystals that cover a surface like this one. We also have stellate, which is radiating individuals that form a star-like shape. So it is like a star-like. And then we have globular, which is radiating individual crystals that form spherical groups or grape-like or blob-like. And then botryoidal, which aggregates of rounded masses. So it is like a smooth bulbous or globular shapes. And then, as a recap, so this one is a radiated shape, and this one is bladed. This one is cubic, sequence, acicular, prismatic, dendritic, reticulated, tabular, stellate, and now we are in luster. So, luster. Luster is a property that describes how light is reflected on the surface of a mineral. So, it is one of the properties that mineralogists look at when trying to determine the identity of a mineral. So, basically, minerals are primarily divided into the two categories of metallic and non-metallic. So, metallic is when minerals exhibit, or it is when exhibiting metallic luster look like metal, such as silvery appearance or that of a flat piece of steel. And then non-metallic luster is the type of luster for minerals that do not look metallic or it is dull or non-shiny. So let's look at this as an example. This one is metallic and this one is non-metallic. So shiny, metal-like, and non-metallic is dull and non-shiny. This one is an example of metallic luster. So copper, silver, gold, and iron. So in non-metallic luster, so we have this non-metallic luster are further divided into different types. So we have pearly, which is also known as mother of pearl, and then vitreous, which is also known as glassy, and then resinous, also known as resin-like, and then greasy or oily, and then adamantine. Adamantine is like a brilliant or diamond-like, and then dull or also known as earthy, and then last but not the least is waxy, which is also known as wax-like. Again, we have two minerals are divided into two categories, metallic and non-metallic. So let's move to transparency or japanity. So transparency is a mineral's degree of transparency or ability to allow light to pass through it. So the degree of transparency may also depend on the thickness of the mineral. So let's take a look at this as an example. So a mineral hornblende is an opaque, means no light can pass through the mineral. And then we also have the diorite, which is translucent. It means that light can pass through the mineral, but it is diffused, which cannot be seen clearly. And then we have here the calcite, which is transparent. So light can pass through the mineral, the image seen clearly. And now to color. So color of so the color of a mineral is actually the first thing that most people notice. So, but the color, it can be also the less useful in identifying a mineral. So most minerals occur in more than one color. Take a look at this as an example. So fluorite. So fluorite can be clear white, or it can be like yellow or blue or green. So in identifying minerals, it is better to use other properties like hardness, cleavage, and luster rather than color. So we have here an example. So which of the following is a quartz mineral? So as you can see, these minerals are all quartz but in different color. So this is an example, or this is a proof that color cannot be a reliable trait in identifying mineral. We also have here the beryl mineral, which also have different color but the same mineral. So in conclusion, color is not reliable in mineral identification. Just like with people, outside color does not tell you much about the important characteristic. And now let's move to streak. So streak of a mineral is the color of the powder produced when it is dragged across an unweathered surface. So this one. So streak can be useful for identifying metallic and earthy minerals. So non-metallic minerals usually give a white streak like this one. It is because they are very light in colored, and then other minerals may have very distinctive streak. Like take a look at this as an example. This is hematite. So hematite always give a reddish brown streak no matter what type of plaster it displays. So breakage. So breakage is the action of breaking something or the fact of being broken. So there are two major ways in which mineral break when you give them a hit. So first is they can break irregularly, in case we say they have fracture, or they can break along parallel planar flat surface, in case we say they have cleavage, like this one and this one. So this is fracture, which it breaks irregularly, and then here the cleavage, which it break along parallel planar flat surface. Again, we have this is cleavage, this is fracture and cleavage. Then let's move to tenacity. So tenacity refers to mineral resistance to breaking, bending, or otherwise being deformed. So here, so brittleness. So brittle is when a mineral is hammered and the result is a powder or small crumb. It is considered brittle. So here, quartz. And then we have sictal. So sictal is when minerals can be separated with a knife, much like wax, but usually not as soft. So like selenite. And then we also have the malleability. So malleability is when a mineral can be flattened by pounding with a hammer. So it is considered malleable. And then flexibility is when mineral that can be bent but remains in the new position after it is bent. It is considered flexible, but it's not inelastic. We only can say it is elastic when it is flexible and elastic minerals are bent, but then they spring back to their original position. And then we also have softness and then tensile. And then that's all. And let's move to hardness. So hardness is the resistance of a mineral to being scratched or its ability to scratch other minerals. Let's take a look at this. This is the most hardness scale. So from scale 1, talc, which is the softest, and then 10, diamond, which is the hardest. So it is tested by using different objects like strip plate, a glass and knife blade, wire nail, a copper penny, and a finger nail. And then we also have these special properties of minerals. So first we have the double refraction. So double refraction happens when light is passed through a special material like the calcite, and it's split into different ray of lights. And then we have the effervescence. So effervescence is a formation of gas bubble in a liquid by chemical reaction, just like this one. And then we have magnetism. Magnetism is when several minerals react when placed within a magnetic field. And then iridescence, which is the play of color or a series of colors produced by interference or diffraction or both, either when light is reflected from thin films. And then fluorescent minerals, it emits visible light when illuminated with ultraviolet light or UV, and then X-rays or electron beams. So that would be all. Thank you. Thank you.